I was teaching one of my classes earlier today, and somehow all my original notes got erased. Don't know how that happened, but so I'm kind of having to look at my book where I was using earlier and kind of go back and forth. Who says there's not already? All right, so this difference of squares. So at the outset, because we go through some of these, so you kind of know what is going to happen, but I'm going to treat it as though we don't. So the a and the b values, these are like the perfect squares of whatever numbers we're going to take the square root of. Okay. So point in case, if I had x squared minus 4, we'll start with an easy one. It's got a minus sign in between the two terms. I look at the first term. Can I take the square root?
No. Yes.
Yeah. It's x. Can I take the square root of 4?
Yes.
2. Okay, so when I took the square root of x squared, that got me x. So that x is it's the a value. When I took the square root of that 4, and I got 2, that...
It's the b value.
Right, that's your b value. So when I put this together now, it's saying, okay, if I have these two numbers squared and there's a minus sign, then I can rewrite them as two binomials, which would look like this right here. X plus 2
And then x minus 2.
and x minus 2. That's your answer. You're done.
Boy, I have a question.
Mm-hmm.
What do you do with that a squared minus b squared?
The a squared minus b squared is representing this problem right here. This is representing
Oh, so
this.
it's referenced. Oh.
It's kind of like the template, if you will.
So a squared minus b squared is the initial problem.
It is, yes. Think of that as this is the factored form. That's the simplified form. Think of it like that.
So, what would you do if you had a b value that couldn't be squared?
Like 3 or 5. As far as this method, can't do it.
Okay.
But we would have to go to a different method to find the factors and the roots and all that stuff.
Okay.
So this is what makes it special, right? Because it's a special occurrence. Good question though. So let's do another one. I'm gonna erase all that. Make one off the top of my head.
Do a. 2 and 45. 6, 4, and.
Write this one down. Now, before you jump too quick, what's rule number 1 of factoring?
Find the square root GCF.
Find the GCF first. That's right out of the gate. No matter what method you're doing, that's the first thing. You good? Right. Does it have a GCF on this one? 16? Oh, okay. So 16 pulls out. So that would be x squared, minus 4. Because we pulled the 16 out at the very beginning, right? What would end up happening if you didn't pull the 16 out is you would have, now this is a perfect square, isn't it? So you get like 4x, and then you get 8, right? So it'd be like a 4x plus 8 and a 4x minus 8. So that's a red flag. If you see something like that, you can go, oh, wait, I probably didn't pull a GCF out because maybe you might just not have considered it.
You need to get the x minus 1.
Oh, we're not solving equations yet. But my point is, if you see something like that happen, just go, okay, I need to back up, pull out a GCF. Easy fix. So the 16 sitting off to the left, this is what we're factoring. Okay? And we did that a second ago, didn't we? So we know the answer, don't we? is it? I'm sorry. My bad.
So why are you only factoring 16?
He means, why are you just taking out 16?
Because that's the GCF.
Well, no, like, I'm,
Yeah. I mean, remember, that's the first thing you always look for.
It's the GCF, but why are you only factoring 16?
Because 16 is the GCF.
Cause 64 don't make any difference.
That's what I'm asking.
Between 16 and 64, 16 is the GCF.
I understand,
Yeah,
but
but you
we
only
ain't doing
factored
anything
it
with
like
that 64.
16s.
Not yet. What we did with the 64s, we pulled 16 out. It just so I think you're confused. Don't think that the first term is always going to be the GCF. Don't make that assumption. It just so happened that was the first term. But you're looking at both numbers, whatever that GCF is. That's what you're pulling out. Okay, so that's why it's sitting there. But yeah, it may be that both those numbers.
So that 4 come from 16 times 4 is
64. Yes.
Oh.
Okay.
Yeah.
The
Yeah.
way I was thinking is you just factored 16 and 16 over.
No. Because remember the GCF is the
But now I realize 16 times 4 is 16.
yes. Yeah. Whatever. Remember the GCF is between the two terms. Yeah.
So how'd you get the bottom part?
Bottom part. Okay, so we pulled the 16 out. So we have this left. This right here is another one of those differences squares, right? So we looked at that, said, okay, square root of x squared, x, right? Square root of 4 is 2. So that's where we got
So
that.
why is one positive and one negative?
Okay, so I'll show you. Because, ultimately you have to get that x squared minus 4 if I refoiled it, right?
Yeah.
Okay, so if I do x plus 2 times x minus 2, watch what happens. That's x squared. That's negative 2x. That's positive 2x. That's negative 4, right? What happens to the two middle terms? And it's left with x squared minus 4.
Is that how it's always going to be? One positive, one negative?
For a difference of squares, yes. Yes, it will.
And it wouldn't matter which one, obviously.
No. So it's same either way.
So really, we're just looking at that, the difference of squares and that.
Okay. Yeah. Oh, I'm sorry. Let me go back. Yeah.
Mr. Connor told me to get released at 1:30, come out with a raise.
130.
It's 132.
Oh. Hey, grab one of these on your way out. Okay. Yeah. Just the odds. All right. So try. Well, I've already done that one, hadn't I? Try that one last one right there. Let's just make sure that you got it.
Don't get too cold. Oh, I'm supposed to be working at 3.
Like I had a mob outside of my classroom. I'm gonna move this over here. There. That'll work better.
I mean, just find the GCF first.
Always check for that. Sometimes it has one, sometimes it don't, right? So that's okay. So did y'all find a GCF?
No.
No GCF?
No.
Okay. So we're good. All right. So the first term, can I take the square root?
9.
9y.
7.
And then
7.
7. That's it.
I like I'm overthinking this.
I do too.
A lot of people do.
That's what I'm thinking.
And write these two. Give yourself a little bit of space because we're actually going to
You said perfect.
perfect square trinomial. Yeah.
So this is
A
different.
minus B.
So on this one, are we just like solving it?
Well, what I'm gonna do with this one, see, just like the previous one had a template,
Yeah.
these two have templates as well. But I'm gonna work you through how they derive it, so it'll make a little bit more sense why everything's works out. Okay. So with the first one, now if I'm saying, let me make it more simple. If I said 7 squared, don't tell me the actual answer, but how can I rewrite 7 squared longer? Okay. So if you see the quantity a minus b squared, what's a longer way to write that?
A minus B and then A minus B.
There you go. There you go. So, and it'd be the same thing with the plus b, a plus b, right? Okay. So, this is like saying this. Okay. So, if I go through and I FOIL this, you know, first term times first term, that's a squared. Outer terms, that's negative ab. My inner terms, so it's negative b times a, but remember, you're multiplying, so it don't matter how you shuffle it. So it's another negative ab. Then the last one, negative b times negative b, which is b squared. Now, what happens here?
A squared plus B squared.
No, whoa.
Wait.
Negative a, yeah, they add. So what is it really?
That's
Negative AB squared, shouldn't it? No.
No, it's negative 2AB.
Negative 2ab, right. All right, so it ends up being,
A squared minus 2AB.
Wait, what's the point of this again? Wait, what is this?
here you go. All right, so here's my point. Just like the previous one had a little template, this one has one too. So if you're able to write an answer as a quantity a minus b squared, here's the thing. My first term and my last term
Are the same.
if they are a perfect square, and if I can take that a and b value, multiply them together, and then double it, and I get my middle term, and I'm gonna show you this in a second, okay? Then I have what's called a perfect square trinomial, and I don't have to do all that x method and that bottoms up method. I ain't got to do all that mess. I can literally do it in my head. Okay, so let's work one out and let me bring some clarity.
On that video that you had us watch, you slightly messed up on the one.
Oh, probably. All right, so this one here. So I look for a GCF. Do I have one?
No, you do not.
No. So, but I'm modeling good practices here, so we always check for that. Second thing is I look at my first term. Can I take the square root of it?
Yes.
And that is
1x.
1x, right. Can I take the square root of the 1 on the end?
No.
I mean, you can, it's just 1 times 1.
Yeah. So the square root of 1 is 1. Okay. So so my a value in this one is going to be x. My b value is going to be 1. Now the question is, can I take 1 and the x, multiply them together? So 1 times x. And then can I double it and get my middle term?
Or which example is this one?
Wait,
First
no.
one. Yeah, the top.
You could.
If you doubled it, that means it would be another.
It's still, it's only 1x times 2, which would be,
2x.
yeah, 2x.
Is that my middle?
Middle term is negative 2x.
Well, okay, so we need to make sure that it's a negative 1, right?
Yes.
We just need to make sure of that.
Does it say negative on it?
Yeah, so because it's going to have to give me a negative 2, right? So, my final answer, you're done. Good one. Ah, here we go. That'll work. Ah.
Is this for problem square?
Yeah, well, yeah. I want to erase that, though. I want to give myself a little bit of room here.
Done.
Does it have a GCF?
No, x squared does not have a greatest common factor of 7.
Oh, no. He's right. Right. To be a greatest common factor, all 3 of them would have to have it. Not 2 out of 3. So, no GCF, but again, that's the first thing we check. So, you're right. All right, can I take the square root of the first term?
Yes.
And that is?
X.
X. Okay. So my A value is x. The last term, the 49, can I take the square root?
7.
Okay, so my B value is 7. Can I take the A and B value, the 7 times the x, and then double it and get this middle term? And that is, so it is a perfect squared trinomial. So all I have to do now is say x minus 7 quantity squared.
Wait, what's the difference between square and, did you say quantity squared?
When you put things in parentheses like that, you say the quantity, x minus 7, or x minus 7 quantity squared. It's just terminology. So the only difference is if that 14 had been positive.
Pardon the interruption, but I need all the volunteers for the cross country to be released at this time. Go help. Thank you.
Okay, so the only difference if that's positive, it would have been x plus 7. That's pretty much it. So now, as far as your notes to be consistent in your notes, we'll go back and put this one in real quick. That would be a squared plus 2ab plus b squared. That would be the difference.
I did that before you even came back.
Let's do one more, and then I'll turn you loose to try some yourself. Oh, that'll work. That works. That works out well. Try this one.
So I got a question.
Shoot.
Without these having a DCF,
Does it have one?
no.
Okay, but that's the first thing we checked, right? All right, so
Take the square root of that?
can you?
Yeah. It's 2.
Well, but don't forget the x squared part, right?
2x.
Yeah.
So your A would be 2x.
Mm-hmm. What would your b value be? There you go. Now, can you take those two values right there, multiply them, and then double them and get this one?
Yeah.
So that's how you know you got a perfect square trinomial you're looking
So
at.
how would I write the answer out? It'd be 2x. Would be plus or minus?
Well, since the middle term's negative, it'd be minus 5. There you go. You did it. That's right. That's right. Where's your notes at? What's this page? What? You should be in your notebook. You don't have paper? I got paper. Like in that bottom cabinet, right underneath my printer, there's like a bunch of it.
After I get here, what do I do?
Pray. All right, so can you take 2x and 5? If you multiply them and then double that, do you get this term right here?
Yes, you do.
Okay, so that tells you this is a perfect square trinomial. Okay, so now you've got to write your answer. Did y'all get it?
No, I don't know what I'm doing.
Did you check for GCF?
There's not one.
Okay, so did you try taking the square root of the first term?
2?
2x. Did you take the square root of the last term?
5. 2 and 5.
That's what I'm doing.
Okay, what would I put? 2 and
So you got 2x, and the b value is 5, right? Okay,
where would the
So-
5 come from?
square root of 25.
But why is that? I thought that was C. Because A, B, C.
I do get that, why that is kind of, maybe I should use x and y or something.
Yeah.
But yeah, it's the first term and the last term. I can understand that confusion. So if you took these two right here, if you multiply them together, and then doubled that product, would you get this number? So that's how you know you're, oh, sorry, I thought it was connected. That's how you know you got a perfect square trinomial.
Okay, so then you can start factoring.
Well, then you just rewrite your answer, right? So there's a minus sign here, so it'd be 2x minus 5 quantity squared.
See?
And you're done.
Okay. I love this stuff. I like it.
Don't forget the, no you didn't. You got it. Yeah, that's it. Okay, so what she did, her A value, which is 2x, was going to the first.
That's the
And-
square root of that one.
Right, right. The 5, which was the square root of this one, went here. Since the middle term was negative, we put a minus sign there. And then we just put the parentheses square.
The reason you're doing this right here is you gotta make sure it's a perfect square before you can start factoring like that, right?
Right, yeah.
That's why we do the whole first part.
It's and don't let it frustrate, because the more of these we do, you'll get better at it. All right, so let's run through the check, because I know we're kind of short on time today. Okay.
I'm actually pretty sure I got it.
So if I take the square root of the first term, I get 2x.
2x and
So my a value is 2x.
the B is 5, isn't it?
The last one, the b value is 5. Okay, so I need to be able to take 5 and the 2x, multiply them together, and then double that
Get the middle term.
to get the middle term, right? And so does that happen?
Yeah.
Mhm.
So then it'd be 2x minus 5 squared,
That's right.
or quant.
Quantity squared. Yeah, you're on the right track. So, so let's wrap up with it. So with every trinomial from this day forward, every trinomial that you run into, now it may not be that you're able to do this, and that's okay, but it's worthy of just a second to check it, because you remember that bottoms up method I showed you, where you got to do the first term times the last, do the x method, then you got to go through, find the factors, and divide. That yeah, it can't. Depending on how big the problem is, it can take a god awful long time, right? This, if it turned out that problem that you were looking at, going, oh crap, if it turned out to be one of these, look how much faster it is to do it. It can save you a lot of time.
Can you put one up there that
Well, I'm about to turn you loose and let y'all try some. I'm sorry, what?
Like, can you do one on the board that would take forever but end up shortening it down?
Well, that we could do it with that and right there, actually. But I don't want to muddy the waters, because I feel like some are here, some are here. You know, I don't want
Some
to
people
cause.
in the middle.
Yeah.
How do you do it?
I'll show you one. Let me see if I can find one. And I'll see. Did 60? Okay. Yeah. Okay. So yeah, I will do it. So one that has the greatest common factor you pull out at the front. Sure. Yeah. In fact, y'all may want to write this one down. This will be a good one. No, I'm actually going to kind of work with you on this one. So, at face value, 12x squared is not a perfect square. 27 ain't a perfect square, right? But, the first thing we really check is GCF, which is kind of what I'm leading into, right? So, what's the GCF of those three terms?
3.
Three. All right, so I pull the GCF out, and I make it look like this. So it'd be 4x squared plus 12x plus 9. So everybody, so far so good? Just like our warm-up, just with 3 terms instead of 2, right? Okay, so now I can go the traditional route, the whole bottoms-up method. But this one, if I take that second, like I was saying earlier, look at these 2 terms. Can I take the square root of 4x squared? Which is 2x. Can I take the square root of 9?
Yes, sir.
All right, if I say 2x times 3, this 3, mind you, and if I double that, will I get the middle term?
That's great.
Now, it doesn't always, it's called a special case for a reason, right? So it don't always work this way, but when it does, it's nice. So when I actually write my actual answer,
It'd be 3 times 2x plus 3.
No, just be 2x plus 3 squared. Oh yeah, 3x.
this 3 right here that I pulled out at the very beginning, I just make sure that I put it right there so I don't forget about it. And that's pretty much the difference. If you had a GCF to pull out first, you just pull it. You kind of forget about it until the very end, and you slap it onto the side. So far, so good? That's actually a very good question. I'm glad you
Would
asked.
you count it wrong if we forgot that little 3?
Yes.
Yes.
Like 100% wrong? Just
Uh,
about a quarter wrong?
a good bit wrong because you're not actually factoring it completely, are you?
No.
You're not accounting for all the factors. It'd be kind of like if I said, hey, what factors make up 6? You would say
1.
2 and 3, right? But if you said 1 and 2, okay, they go into 6, yeah, but it's not all of them, right? You got to be thorough. Okay. So up here.